On Thursday, we looked at this problem. So we had a force at point A, and the force was 735 newtons, and we found out what the components of the force was. And then we were looking at trying to find the moment about point C. And we solved for the moment about point C in two different ways, one using right-hand rule and one using vectors. And now I want you to talk to the person next to you, and I want you to figure out how you would find the moment about line CD. You know the moment about point C. How could you find the moment about line CD? What did I say last week about when you're confused about moments? What do you think of? Forces. Okay, don't just talk to the person next to you. Don't say it out loud. So you know what the moment is about point C, and I want you to find out the moment about line CD.
So you use this force.
You know what the moment is about point C, and I want to know what the moment is, what the spin is around CD.
No, this is it. No, this is it.
Think about it in terms of forces. You had the force on point C. How would you find the force that's along the direction of CD?
The same force? Really? You got the same force? This force? Dotted at the beginning?
Okay, let's look over here for a minute. So here's the x-axis, right? It's pointing out towards you, and here's the y-axis, and here's the z-axis. And this force, so let's just look at the origin for now. Okay? So if we have the origin and we have some force coming out here, and I want to find the component of this force in the direction of this, or in the direction of something weird, some weird line, think about how I would find the component of this force in the direction of another line. And what we're looking at here is, you know the moment, not the force, you know the moment about point C, you know what the spin is about the axis coming through C, and you want to find the component of that moment along CD.
Each moment at C and each moment at
It's a
Oh, yeah. So you have that, and then you got that one.
That line, that
We want the moment
Because that would be
around that one. Yeah, just like a point, like the moment around that one. From the force.
Maybe. One going this way, and this one going this way.
break them?
No, kind of.
Okay, so let's think of it in terms of forces. We're gonna say, we know what the force is about C. And we're trying to find the force along line CD. How would we do that in terms of forces? We know the force that's going in the C direction. How would we find the force that's going along line CD? Who wants to answer it, Wes?
We're not going to integrate, right?
No.
Dot product.
That's nice. I was thinking about it. I mean, the force along every single point along that line, but we're not going to get that hectic. So
Eric?
that was my plan for it.
Add the moments in C and D and take the difference.
It's a C and D. No? No. How about Joe? Okay, so let's ask a different question. I'm going to step back. I'm going to say that I know the force C, and I want to find the component of C in the x direction.
Dot it?
Dot it. So what do? I say FC, and I dot it with what?
Unit.
Unit vector in the x direction, right? So this is the vector that I know, right? This is the vector I know. This is the line that I want to know the force in, right? So basically, I want to find the component of force C in direction of the x-axis, right? Everybody agrees with this, right? We already know this. So let's go from here to here. Tara, if I know, sorry, Karen over there. Peter, did you go?
No.
Oh, Karen. So if you know force C and you want to find the direction, the component of that force along CD, what would you do?
You dot it with the unit vector of CD.
Yep. Wouldn't this give you the component of FC in the direction of line CD? Right? Does everybody agree with that? So this we already know. We're comfortable with this. We're comfortable with finding x, y, and z components of forces, and we know we use the unit vector. You know we use dot product. But we can find the component of any force in any direction. So now, Peter, this problem that I have up here, I know what the moment is about C, and I want to find the component of the moment about C in the direction of CD. So what do?
You do moment C times the unit vector.
Times
Oh, sorry, no.
dot product.
Yes.
And that's what we get. So we come over here. So we have the moment about C. So Paul, if the component of the moment C in the direction of CD is this, I need to find out what this unit vector is in CD, right?
Right.
So let's calculate that first. So going from C to D, how much am I going in the x?
Negative 100.
Negative 100, I. How much is going from C to D, how much am I going in the y?
0.
0, so I won't put anything. Well, I'll just put 0, okay. And then how much am I going in the z?
120.
120k. And it's a unit vector, right? So I have to put it under this.
Yeah.
And what does that come out to be? I have negative 0.6400I plus 0.7680k. And what unit is a unit vector? Unitless.
I got 156.7.
What, you mean on the bottom?
The denominator.
Okay.
I did it right.
Did somebody else get this? A negative 0.6400? and a positive 7680. Yeah, okay.